We got this cute little baby bird problem. Y'all should come up with a name for that baby bird and like write it on your homework or something, man. But letter A says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? This, you know, that notation, that's just your derivative. So that's going to be like how fast that little baby bird is gaining weight. And so if you want to compare those, we're just going to take the 40 and the 70, and we're going to plug that into the first derivative right here. So when I plugged in B equals 40, basic arithmetic, got 12 grams per day, plugged in B equals 70, got a fifth of 30, which is 6 grams per day. And so there's my work, there's my justification. And I just said it's gaining weight faster when that bird weighs 40 grams, which kind of makes sense. You know, I'm sure you would like gain weight faster as you're like growing up and stuff. And now it kind of like evens out a little bit, you know, so I don't know. But as you're smaller, you know, weighing less, and you know, you're gonna start growing a little bit more there. So like, yeah, just drink that milk, man. So yeah, 40 grams. That's our answer for part A. And in part B, it tells us to find the second derivative in terms of B. Now, you'll see a few problems like this before we actually take this test, but you're going to take the derivative of that first derivative. So I wrote that down here so we can see everything we need right here. There's our first derivative. I'm going to take the derivative of that. So this is just a constant. I carry the constant down. This is like a 100 minus x on the inside. So the derivative of 100 minus x is -1. So the derivative of 100 minus b is also a -1. But what we'll do, we'll tag on a db dt. And that's why the direction is stressed in terms of b, which means you're supposed to get rid of that first derivative. So you just replace it with what it's equal to. So plug in that for the db dt and then merge it together. You got the -1/25. So that's the first part of part B, is just taking that derivative, finding the second derivative. And then, so I thought that was pretty straightforward, but I understand like the first time you're seeing it, you might forget to do that. And so now you know, all right? So you'll see stuff like that in the future. The second part of it, I had to think a little bit. It says, use the second derivative to explain why the graph of B cannot resemble the following graph. So this is like the wrong graph. We got to use the second derivative to explain that. At first, I was like, I don't even know what I'm supposed to do. But then I thought, okay, what do we always use that second derivative for? We use it to tell us about concavity of this thing. So as I looked at this graph, I said, okay, part of this graph is concave up, part of this graph is concave down. I don't even know. So then I was just staring at this for a while, and it took a few seconds for it to pop into my head, but I'm thinking, okay, in between this 20 and 100, right? That whole graph is below 100. So I'm thinking, okay, whenever B is smaller than 100 or in between that 20 and 100, we're going to do a 100 minus a number that's smaller than 100, which this part then will always be a positive number. And then you're always times it by a negative number, which means that second derivative right here is always a negative number. So if that second derivative is always a negative number, that means our actual graph should always be concave down, and this graph is not always concave down. So I just mentioned, hey, that second derivative should be negative, and that graph should be concave down right there. And then letter C, we are gonna be perfect and just experts at stuff like letter C, okay? This is our wheelhouse, this is gonna be our strength of ours. It says use separation of variables. Sometimes people get confused on that. That's just getting the y's with the dy, x's with the dx. But when you see find the particular solution to the differential equation, that's even in your blue packet, it tells you what to do. Not the first time we've seen one of these. These are when you're gonna integrate both sides, remember the plus C, use the given point, the initial condition to plug it in to figure out what that C value is, and then solve that thing for the Y or the B in this case, okay? So the first thing I did was multiply both sides by the dt, and then you have to do legal algebra. You can't like add b to both sides, right? It doesn't make any sense. It's in the parentheses. This is all multiply and divide stuff. You're gonna divide both sides by the 100 minus b. You have to get the b's with the db and any t's with the dt. It doesn't matter what you do with the numbers. Typically, I don't like to put extra numbers over there because you're gonna have to move them back anyways because you gotta solve for like the b at the end of this thing. But that's what they mean when they say separate your variables and then you integrate both sides, right? That's an easy integral. Always put the plus c on the side the x's are on. Be careful here because your u is that bottom part. Your du is a -1, so you got to balance that with a negative, and you do get 1 over a single letter, which is going to be an ln integral right there. And then they give you the point 0, 20. That's your x, that's your y. So plug the 20 in for the y, plug the 0 in for the t or the x. You get your c value, plop that back in right there, and then You'll see a lot of these that have the E's and the LNs in there. I think we would be happy if we just develop some consistency with how to work those out. Like when you have LNs on the same side, what I like to do, it always gives me a nice answer when I do this, is I move all of my LNs on the same side. So I just added that over there, group together your LNs, because now you can use your pre-cut properties and merge them together. And then you can use your main definition of a log, where you can go e to the 1/5 t equals that 80 over 100 minus b. And then you got to solve this for the b, because it says y equals b of t or b equals y. You got to get that b part by itself. That's like your y variable on this problem here. So you got to solve this for the b, multiply by the denominator. So I did two things at once here. I multiplied by the denominator and I divided both sides by the e. And then what I kind of did in my head, I moved the b over here to get it positive, and I subtracted that to that side to keep that negative. And I looked at the rubric. The rubric on this one even accepted if you left it as 80e to the negative 150, like they would have given you full credit for that. But that's worth, you know, a chunk of the points right there. And then typically, I haven't sure about this exact problem, but typically these are worth 5 or 6 points there. And if it's, let's just say it's worth 6 points for letter C, then you typically will get 1 point if you separate your variables properly. You get 2 additional points if you just integrate properly. And if you forget the plus C, you don't find that at all, the max you're going to get is 3 out of the 6. So you got to remember to put the plus C in there right away. And then if you could correctly find that C value, then you get 2 additional points. So just like right here, I got 5 out of the 6 points in that problem as well. But usually the solving part, if you do make a little mistake in there, it's going to be like a 1 point deduction. But usually we're going to knock that out anyways there. I want you to kind of study your strengths. And this is going to be something that you just want to make sure you get 100% of the points on right there. All right, baby Bird, Larry Legend.